Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 41 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at SunFounder. SunFounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the SunFounder Raphael kit for Raspberry Pi. Now, most of you guys probably already have your gear. If you don't, look down in the description. There is a link over to Amazon. You can pick this kit up. And believe me, your life and my life are going to be a lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and let's talk about what I am going to teach you today. And what I'm going to teach you today is really a follow-on to the material that we've been talking about in the last two lessons. And the theme that we've had in these last two lessons is how to start creating projects and prototypes that we can actually deploy. And to deploy our project or our prototype, we need an ability to remotely connect to the Raspberry Pi. 2 lessons ago, what I taught you is you can SSH in with PuTTY, and you can open up a terminal on your PC and you can connect to the Pi through that terminal. So anything that you could do on a terminal on the Pi, you can do remotely on a terminal. Then some of you guys enjoy the comfort and ease of use of having a graphical user interface. So last week I showed you how to run a remote desktop for the Raspberry Pi. So the Raspberry Pi's desktop appears as a window on your PC and to be able to connect up through Ethernet or Wi-Fi. So we've learned those 2 methods. But in reality, you really want something that's a little cleaner connection. You don't want to run necessarily the overhead of a full remote desktop. And also, you would like to do things more than just fire up a window. And so really what you would like to be able to do is run a program on the Raspberry Pi and then exchange data back and forth between your PC and your Raspberry Pi. And this is kind of what you would call like this would be like remote data exchange. And I'm going to show you how to do that very simply and very robustly today. Does that sound good? I hope it sounds good. So let's see if we can come over here to this view. Okay, and so what I will need you to do is fire up your Raspberry Pi. And then after firing up your Raspberry Pi, I need you to go ahead and open up Thonny or whatever IDE you like to use on the Raspberry Pi. I like to use Thonny. And let's see if I can get this thing down here. Give me just a second. I've got some multiple window business going on. Okay, there it is. And what I'm going to do is I am going to call this program rpiserver.py. You can call yours whatever you want, but the .py is kind of important. So this is the way it works. This is, we're going to initially be setting up a client-server type relationship. And then I'm going to show you in today's class and in the next couple of classes how to do that. Now, today's class, we're just going to be passing the data back and forth. I'm going to show you how to send data from the PC to the Raspberry Pi and then how to receive data back from the Raspberry Pi to the PC. So I'll show you what commands are needed to send the data both ways. Okay, now once you know that mechanism of transferring and receiving the data, then we want to set up together a little bit more of a formal client-server type relationship. Now, usually the Raspberry Pi is taking data, monitoring, it's doing something. So in most cases, your Raspberry Pi is going to be the server, okay, and your PC is going to be the client. Your PC is going to want something, it's going to order it, and then the Raspberry Pi is going to serve it up. So I like to think of it kind of as a McDonald's. The person that works at McDonald's behind the counter, they are the server, and me, the customer, I am the client. I come in, I say I would like a Big Mac. The person working there gets the Big Mac and hands it to me. They're the server, I'm the client. That's the way I like to look at it. And as we're developing the software, you want to kind of keep that model in mind. And so we'll have a Python program on our PC that is sending commands or sending things that it wants to the Raspberry Pi, and then the Raspberry Pi will send those things back. And so you've got to think of that client-server type relationship. Okay, how do we do that? We do that with something that's called a socket. I'm going to plug into the socket at the server side with the Raspberry Pi, and then the client is going to plug into the other end of that socket, and they're going to talk to each other through the what? Through the socket. So if we're going to do that, we are going to need to import socket, and I can see that you guys are not going to be able to see that, so I need to come in here and do options, and let's see, we're going to come up to editor. Where would that be? We need a bigger, oh, there it is. Okay, let's make this about 26. Yeah, I think you can see that good. Sorry for that, but I know it's a lot easier for you if I just take a second and get this set up. We also might want to put some delays in, and so we're going to go ahead and say import time. I just do that because usually I end up needing it. Okay, now we're going to be sending packets of data back and forth. So I need to set up a buffer size. Now your buffer size is just the space that you reserve for the message or the data. The data doesn't have to be this big, but I like to make it big enough that I have plenty of room to have a holding spot for the data that I'm going to send or that I'm going to receive. So I'm going to go ahead and say buffer size, like that. Buffer size is going to be equal to 1024. That would be a nice large buffer, plenty for anything that we're going to be wanting to do. Now I'm going to have a message from server. Okay, so I want to send something. There will be something that goes from the server back to the client. So let's just go ahead and set that up. You can imagine in a real application, this message from the server might be data, information, measurements, any number of different things, but I'm just trying to show you how to get a client to ask for a packet and then how to have the Raspberry Pi send that packet. So we need a packet. So it is going to be message from server is what we're going to say. And the server is going to say howdy client, because the server is talking to the client, and happy to be your server. I really like to make polite servers and clients. I think computers should be polite to each other. So I think howdy client, happy to be your server is a pretty polite thing to say. Now I need to say what port that this server is going to be listening on. Okay, so there's all types of ports on your computer. Which port is the Raspberry Pi going to be listening to? So I will say server port is going to be equal to 2222. Now you just don't want to use one that's already being used, but 2222 is a reasonable thing to use. Okay, now I have to put in what is my server IP. Well, how do I learn that? I come over here and I open up a terminal. I'm going to put in ifconfig. We've done this before, so that should be familiar to you. And you can see that my IP address is 192.168.88.41. You need to look and see what your IP address is. You need to use your IP address, not my IP address. Okay, so let's get that out of the way. And now I am going to say server IP like that. And now you need to put these in quotes, okay, like that. And so now the program knows what its own IP address is. Okay, now I have the message that I was going to send, but now I need to convert that into bytes so that it's something that will just slide right down that socket. And so I need to create a bytes to send like that, and that is going to be the message from server that we created. We created that up here, right? The message from server, okay? But what I need to do to that is dot encode to make it the right byte format. And I'm going to go ahead and just make it UTF-8. You don't have to worry about that, but I'm just giving it a good format. And then as long as we're using the same format on both sides, it will work. So I have the message to send, I have the byte to send, and now what do I need to do? I need to create the socket. So I'm going to say the RPI socket, is going to be equal to socket, that is the library, dot socket, which is the method, and then it is going to be socket, again the library, dot, we need to tell it that it's AF underscore INIT, and that's just setting up some parameters there, and then socket dot sock underscore DGRAN. Okay, so what I'm showing you how to do here, I'm showing you that the easiest way to just send chunks of data back and forth over Ethernet or over your local network is UDP. You could do RSTP, you could do HTML, you could do RTP, you could do all these different RMTP, you could do all these different protocols, but for little discrete individual chunks of data coming back and forth, UDP I think is the best. And the way you set up the UDP is with these parameters. Now if you wanted to do other methods, you would use other parameters, but it's the AF underscore init, and it is the dot sock underscore DGRAM for UDP. Now, if you want to do this, this would be years you could spend understanding what all your different options are, but I'm showing you one way that will work and it's simple to do. Okay, now I need to take that RPI socket that I created and I need to bind it. Okay, I need to bind it. Where do I bind it? Well, I need to bind it to my server IP and I need to bind it to my server port. Okay, so now what does this do? When I talk to RPI socket, I am going to be talking to the socket at my IP address and at that port. So now I know where I should talk to because I have bound my RPI socket to the IP address and the port. Remember, all of this we're doing on the server side. Now, I have connected. So what do? I'm just going to say print server is up and listening. Okay, so what this means is what you have to see is what does a server do? The guy in McDonald's, what does he do? He sits and waits for a customer to place an order. He's sitting there listening to see if someone is going to order something. So what do? We are going to sit and we're going to wait. We are up and listening. And how do we do that? Well, we're going to look for a message and we're going to look for a message from an address. So there are going to be two parameters that we're going to be listening to, a message and an address. Where do we get it? From RPI socket. And then what do? We receive from, like that, receive, R-E-C-V, F-R-O-M. And where are we going to receive from? We are going to wait for up to buffer size. Okay. Now, how does it know where to be listening to the message? It's listening on the RPI socket, and the RPI socket has been bound to the server's IP at the server port. Does that make sense? Okay, so it's sitting there listening. It will sit at this step and pause. until when? Until it hears from a client. Does that make sense? Now, once it hears from the client, then what it is going to have is it is going to have a message. That's the message that was sent, and it's going to have the address that it came from. Because you got to remember, the Raspberry Pi might be sitting here as the server, and I might have 10 computers around the network, each one who is placing orders. Okay, so typically you have one server, the guy behind the cash register, and you have a lot of customers, you have a lot of clients. And so what this address is here, it's the address of the client that is placing the order or making the request. I hope that makes sense. So let's go ahead and we have the message, but now we're going to have we need to decode the message. So I'm going to say message is equal to message is equal to message dot decode, and then how do I want to decode it? As UTF-8. Okay, so I encode my message and I send it, and then when I get the response back, I have to decode it, and I need to be talking in the same format here. Okay, so now let's just see what the message was. So I'm going to print what? I'm going to print the message. Does that make sense? Hope it does. Okay, and then I'm also going to print, let's see who is talking to us. So I'm going to print the client address. That's whoever just sent the message. And then what would that be? That would be address, and then it is going to be 0. All right. And so the address comes in two parts. What? The IP address and the port address. And so I'm just going to print the IP address of the client that sent the message by doing this right here. And now I've gotten the message. From the client. I need to respond. So I'm going to say RPI socket. Okay, RPI socket dot send to, and then who do I send it to? Bytes to address. Does that make sense? I'm sorry, bytes to send. And remember, I set that up way up here, the bytes to send. That's the encoded message. And then who do I send it to? Address. All right. Now there's one thing that I want you to see here. You notice how I'm not typing in the client's address. I don't know what the client's address is, but when the client makes a request, he sends his address and then I send back to them. So really the IP address that you need to know is you need to know the server IP address, and the client IP address can be anything, because whoever you are, when you send the request, then the response goes back to you. And so now what have I done? I have set up the socket. I bind to the socket. I listen to the socket. When a message comes in, I decode the message, I print the message, and then I send a response back. Does that make sense? Now this isn't going to work. And why is this not going to work? Because there's not going to be a client that's doing anything. But let's go ahead and run this and just see if, okay, I've got an error here already, and this is quite annoying. Okay, where did I make my error? Line 8. AF init. Did I make a mistake there? So socket is equal to socket INET, like that. Okay, AF init. That's why I like to run the program as I go, and I can find these simple little mistakes. And now let's run it. Okay, and again, it is not happy. And let's see, line 9. Takes bind takes exactly one argument and 2 were given. And so let's see, you send this as a tuple, and a tuple would be one parameter. So you see, I sent it as, one thing, and I sent it as another thing, but you have to send only one thing. So we have to make this a tuple by putting another set of parentheses about it. Okay, so now I am sending one parameter. That one parameter is a tuple that has two values. Now let's try it. Okay, server is up and listening. Boom. So that's good. And I guess you can't see that because it is behind the title. Let me just show you that it's working. Okay, so you see server is up and listening. Okay, so that is really, really good news. So on the Raspberry Pi side, I have a server set up. That server is sitting and listening for data. So what do I need to do now? I need to write something on the PC side. So what I'm going to do is I'm going to switch over to the PC. And here we are. So this is my PC. You see now I've got to change my keyboard so that I'm typing on the PC. And what do I need to do? I need to write the software for the client. Okay, you now know how to set up a server. You now need to know what? You need to know how to set up a client. And it's very, very similar, and you'll recognize a lot of this from what we did earlier, and it is just as simple, and there's only a few different little things. So the first thing I need to do is I need to import socket again. Okay, and then this time I need a message from client. Okay, and the message from client, let's see, the message from client is going to be howdy server from your client. Okay, and I write it this way just so you can kind of be thinking of the difference between a server and a client. So the communication is going to be initiated by the client, and he's going to say howdy server from your client. Then what do I need? I need to make that bytes to send. I need to encode it, and so that's equal. That's going to be equal message from client. Message from client dot what dot encode, and then how are we going to encode it? With UTF-8 like that. Okay, UTF-8. Now, the client will automatically put his address, his IP address, when he makes the request, but the client needs to know who to talk to. So the client is going to need to have the server address. The client is going to need to have the server address, and then what do we know the server address is? We know that it is 192.168.88.41. Use your server address. Don't use my server address, okay? And this is the Raspberry Pi address. This is not your PC address. It is the server address. And that's something people get confused about. Over on the client side, they start trying to put the client IP address in. No, we're only dealing with one IP address. That is the server IP address. Okay? And then what else? We need an equal sign there, don't we? The server address is equal to that, and then that should be in our quotes. That should be in our quotes. And then what else do we need? We also need our port, and so we're just going to do the 2222 again, because I need to be talking on the same port that the Raspberry Pi is listening to. So that's the server address. And I better spell this business right. Server address, like that. Okay, does that make sense? Now again, we got to tell it the buffer size, and that's going to be 1024, because that's what it was on the other side. Now I'm going to create a UDP client, and that UDP client is going to be equal to socket the library dot socket the method. Okay, and then what I'm going to do is socket dot af underscore init, like we did on the other side, and socket dot sock underscore dgram. So you can see the socket I'm creating on the client side is the same type as the socket that I'm creating on the server side. Does that make sense? I hope it does. And they're both, they're both kind of the identical thing. The server and the client, you set the socket up the same. And I hope that sort of is intuitive and makes sense. So now I've got it set up, and now I need to send a command to the server. Why? Because the contact is initiated by the client. So the client needs to do something. So what the client is going to do is a UDP. Okay, it is going to do a UDP client, a UDP.client, okay, or UDP client dot send to. And you've seen this send to before, right? Because we did a send to on the other side as well. But this time, what are we going to send? Bytes to send. That was our encoded message. And where are we going to send it to? The server address. All right. Now, what is the difference between the two send tos? On the client side, on the client side, the server address is hardwired in as the Raspberry Pi's IP address as the server, okay? But when we come back over to the Raspberry Pi to the server side, on the server side, the IP address, the address that we send to here, the address that we send to, we get here, okay? It's part of when the client sends a request, the client sends his own IP address and port. And then we get that, and whoever it came from, we send back to them. Does that make sense? And that's why it never visibly really comes out what the client's IP address is. And so pause the video and make sure that makes sense, because that's kind of the important thing in the distinction between a client and a server. Okay, so now we send to the server address, we send it bytes to send, which is the encoded message, okay? And then after we do that, we wait for a response. So let's wait for data, and then let's wait for address. And so again, the server is going to send us the data, and it's going to send its address back, okay? Even though we already know it, we've got to have a place to catch it. And then what is that going to be? It is going to be UDP client, and then what? Do you remember? Do you remember what it is? RECV from, and then we're going to receive what? Buffer size. Now you kind of would think in here you would want to put like the address or something. No, the address is included already because UDP client was set up to talk to the server address. And that was because we sent to it there. It already knows where it should be listening to, if that makes sense. So here we send to the server address, and then therefore it knows to be listening at that same address. Okay? So now I have data and address. And so then I'm going to convert data. So I'll say data is equal to data.decode, and then data is equal to data.decode. And then how do we decode it? We need to decode it as the UTF-8 like that. Okay, so we data decode. That looks good. And then what I'm going to do is I'm going to print, and I'm going to print data from server, and then what? Data. And that should be the message. Okay, and that message should probably be a string. And then I'm also going to print, server IP address. And then what is that going to be? That's going to be address in position 0, the first element of the address array. And then I'm going to print server port. server port like that. And then that would be address 1. Close that. Okay, so what happens? The client is sitting and listening. Then the server, the server is sitting and listening. Then the client sends a request. The server reads the request and then responds. And then the client gets the response back and prints it. Does that make sense? Look at the code of these two programs and make sure that you understand what's happening. So if we come back over here, give me just a second. If we come back over here, I need to get a good view of this, and it'll take me just a second to get my Windows management taken care of there. Okay, I think you'll be able to see that. So if I come over here, I'm coming back to the Raspberry Pi. And what you can see on the Raspberry Pi side, the server is already running. It's up, it's running, and it's what? Listening. It is waiting for data. So now what I will do is I will come back over to this side. Okay, I will come back over to the PC side, to the client side, and now I'm going to run the program. Now when I run this program, what is it going to do? It's going to send a message, and it's going to wait for a response, and then it's going to print the response. So if I say run module, okay, must be saved, okay. This is quite annoying. We will say client udp.py like that. That looks good. Save. Okay, so we get an error. So it says, oh, you can see I made a typo. Hopefully you guys were yelling at me when I do that, but it was message to send is message MSG like that. Okay, let's try it again. And this time it doesn't like line 6, cock it. Not cock it. Hopefully you guys saw that. So 1, 2, 3, 4, 5, 6. Socket. Like that. Okay, you guys have probably been screaming at me. Okay, line 7, UDP client is not defined. What? Oh, L, uppercase L. Okay. And guys, part of the problem is in my studio here, the window that I am programming on is way in my periphery vision, and so I don't want to turn my head sideways, and so I'm not getting a good view at it. At least that's my story, and I'm sticking to it. Okay, now let's see, run module. Okay, now this time what is interesting is it seemed like that we got not a crash, but we didn't get anything back. Okay, so it says, okay guys, as I'm looking at this, things really look right. I am looking here at the client side, and I come over here and I look at the server side, and the only thing I can really figure out is when my program crashed, maybe I like left that socket locked onto or something like that. And so what I think I'm going to do is I'm just going to come and rerun the server. So I'm going to stop the server and I'm going to run the server. All right, now I'm going to come over to the client, and then I'm going to run the client, run module, and boom, do you see that? Okay, so what do we have here? We have a message, data from the server, howdy client, happy to be your server, and then it gives me the server IP address and the server port, which I already knew, but this is, you know, I sent to that address, it sent me its address back, and the address it sent back is where I was talking to. So that's just kind of a sanity check. And then what we can do is we can come back over here to the server side, and you can see that the server had the message down here. The server got the message from the client, which was howdy server from your client, and then client address is the client address, that was the address that came from the client, and so that was very good. I'd put a little line in here to help with my debugging, so I will take that back out. Okay, and let's just try this one more time. We will run the server. All right, now we are going to switch over to the client. We're going to switch over to the client, and now we are going to run the client again. Okay, boom. All right, now let's go back and look at the server. And the server is working correctly. Okay, so this has been a little bit tedious, but with these two, kind of skeleton programs, it shows how you can send a message to the server from the client, and then you can respond back from the server to the client. So let's look at how we might do this, because you've got to kind of get a little bit more action going than what we have here. So let's come back and let's just write a simple program where the client would instruct the server to either increment or decrement a counter. And that should be something that would show us a little bit more of having a little meaningful conversation going. And so what we're going to do is we still need to come up here and do all the stuff that we did before. We're binding we're binding the port, and we're saying that the server is up and listening. I need to go to my other keyboard. And so what we're going to do is see if we can send a command to increment a counter or decrement a counter. So we will be listening for something, and then I'm going to do a while true. When is true? True. True is always true. And then I'm still going to look for the message, and I'm still going to do these things. All right. Now, what I'm going to do is I'm going to be looking for the message, but I'm also going to have a counter. So up here, I will set the counter to 0. So CNT is equal to 0. All right. Now, I think that I will come here and I print the message, and then I print the stuff as I did before. But now what I'm going to do is, that should be tabbed over as well. Now what I'm going to do is I'm going to say if message is equal to INC for increment, then what am I going to do? Then count is equal to count plus 1. All right. But what do I do if the message is equal decrement, DEC? In that case, CNT is equal to CNT minus 1. Like that. All right. Now, what do I want to send back? Now, I don't want to send back bytes to send, because that is that message up there. So what do I need to do? I need to say message that I'm going to send back is going to be the string value of count. Okay, and now I need to encode it. So MSG is equal to MSG.encode, and then how am I going to encode it? UTF-8, like that. All right, and then what am I going to send? I'm going to send message, because it is encoded MSG. Like that. Okay, let's just run this and see if this thing will run, if we didn't do something crazy. Okay, server is up and listening. That's good. Now let's see if we can come in and do something smart over on the client side. And so here, similarly, I'm going to come up here, and I've got the socket set up. And so what I'm going to do here is get the correct keyboard. I'm on the client side. I'm on the PC now. And so again, I'm going to say while true. When is true? True. True is always true. All right. And then what I will do is I will say CMD is equal to input, and I'm going to input, and it'll say, what do you want to do with counter, inc, or dec? That's my prompt. That's my prompt, and I'm sticking to it. All right. Now what I want to do is I want to say cmd is equal to cmd.encode in UTF-8 like that. And now what am I going to send? I'm going to send command to the address. Right. Now I'm going to wait for a response back. I'm going to get my response. And then I'm going to decode it. And then I'm going to print it. All right. So there's probably an error in here, but let's just run this. So right on this side, I'm going to be telling it increment or decrement. Okay, let's say I want to increment. Okay, data from server is 1. Okay, that makes sense. Okay, what do you want to do? I want to increment. 2, Shazam, it's going up. What do I want to do? I want to increment. Boom, it goes to 3. And let me make sure you can see that. Okay, so Python on the PC, the client is sending a command to the Raspberry Pi. The Raspberry Pi, the server, does what it is commanded and then serves the result. And so let's come back down here. Okay, this time let's inc again. Okay, and then let's just say if I didn't do it as I was instructed and I typed in something like that, it takes it but nothing happens. Now let's see if dec works. Dec goes to 3, dec goes to 2, dec goes to 1. Okay, this is what you guys wanted to see. This is how to send data one way, how to get the data back. All right, guys, this is pretty darn exciting. Okay, so I need to give you guys a homework assignment. So I think I've shown you the core skeleton that you need to create a client server type of system. I've sort of explained the client server to you. I've shown you the 3 or 4 commands that you need in order to make it work properly. And so this is what the homework assignment is. Let's do something a little bit more realistic now. What I want you to do is to take the Raspberry Pi, the server, and I want you to connect it to the DHT11 temperature humidity sensor from the SunFounder kit, and then I want you to be sending the data from the I want you to be sending the temperature and humidity data from the sensor back to the Python program, the client that is running on your PC. Okay, now you've got to think you need to do it as a client-server type relationship. So you really got to be thinking, what should the Raspberry Pi really be doing? And you've got to really be thinking about what should the PC, the client, really be doing. And you've got to set this up thinking correctly. Thinking how? Thinking in terms of a client server relationship. All right, guys, I hope this wasn't too tedious, but really it's just, you've got to know, you've got to know that you've got to bind on the server side to that port, and you've got to know these 3 or 4 a little bit tedious commands. But once you know those things, then the world really is your oyster. And guys, I hope you're really enjoying these lessons. Hey, I've got a new camera. I've got a new river view. You guys let me know. This is the new river cam, again, live here. And you can see it's a little bit wider angle view, and it shows my yard. It shows my front yard, and it shows the river. I kind of like this because you see the greenery and you see a little bit more. But then I also kind of like the classic cam, which is looking at the same area, but it's just zoomed in more. And so this classic cam here is looking at that. You can see the palm tree. It's just kind of zoomed in on that little area there around the palm tree. You guys let me know which camera you like better for my background. Okay, so you've got your homework assignment. Your homework assignment is to go in and what you need to do is you need to have the Raspberry Pi taking temperature and humidity measurements, which it sends to the to the PC, and you've got to do it in a client-server type relationship. Better figure out, first of all, who's the client, who's the server, and then you better set things up in a logical fashion. Okay, guys, Paul McWhorter with TopTechBoy.com. I will talk to you guys later.